Alright, welcome to Best Academy TV. In this video, we'll be looking into this topic, calculation on sound waves in a vibrating string. We are going to look into overtone and we are going to look into harmonics, okay? But before we solve some questions on harmonics and overtone, let's know more about what is harmony. Let's know what is fundamental frequency, and let's know what is overtone. Please write. Fundamental frequency or threshold frequency is the frequency calculated from the equation. Is the frequency calculated from the equation or the frequency found in the equation. Please just understand this. This is the mathematical definition here. The frequency calculated from the equation given to you in terms of wave, or the frequency given in the equation already. Please take note of that, okay? It can be denoted as f of naught. Now, the next frequency I'm going to look into here is said to be harmonics. All right? Please write. Harmonic frequency can be defined as frequency gotten from fundamental frequency. Frequency gotten from fundamental frequency. Now, that frequency we calculate from fundamental frequency is said to be harmonic frequency. Mathematically can be expressed as Fn is equal to n f naught. Please take note. Now, this m here is said to be the number. If you're asked to find f, the first harmony, that means m will be equal to 1. If you're asked to find the second harmony, m will be equal to 2. Please take note. While f naught here is said to be the fundamental frequency. Now, the next frequency we are going to look into here is said to be overtone frequency. All right. Now, most students always have problem whenever they are solving overtone frequency. So I'm going to explain more on overtone frequency relating to fundamental frequency, and I'm going to solve overtone frequency relating to resonance tube. Please take note of that, okay? Now let's try to know overtone here. That is over the harmony. The frequency over the harmony is said to be overtone frequency. Please take note. The frequency over the harmony is said to be overtone frequency. All right? Now let's take the mathematical formula here. Mathematically, Fn is equal to m plus 1 f naught. Please take note. So class, if you are given a question and you are asked to find overtone frequency, at that point, this is the formula to use. But if you are given a question and that question is on resonance tube, at that point, the overtone frequency is going to be, please listen, the overtone frequency for overtone frequency as, let's take a note of the formula for overtone frequency for resonance tube, please, is given as Fm, okay? Take the formula for overtone frequency for resonance tube. The formula is given as Fm is equal to 2n plus 1 times f naught. Now listen, this is said to be the number of the frequency. If you're asked to find the top frequency, that means n will be equal to 3. Okay? Now Fm is said to be the fundamental frequency. Class, listen. If you are given a question and you're asked to find the overtone frequency, and that question is not basically on resonance tube, at that point we use this. But if you are given a question and you are asked to find the overtone frequency, and that question is on resonance tube, at that point we use this here to find the overtone. Please take note of that. Let's solve some question here to understand overtone, fundamental frequency, and harmonies. Okay? Question 1, please. All right. Now, our intention here is just to understand everything about harmonies, fundamental frequency, and overtone just within some minutes. Okay? Don't be afraid in case this topic is a kind of scaring to you. Okay? Now, but let's understand the question here before we solve the question. All right. Now, the lowest note emitted by a stretched string has a frequency of 40 Hz. How many overtones are there between 40 Hz and 150 Hz? That means it will be between 40 Hz. If you have 40 Hz is included, it will have 150 Hz is included, but it should not be more than 150 Hz. Please take note. Just like if I have 1 to 5. That means if I have 1, that means it's included. If I have 2, it's included. If I have 3, it's included. If I have 5, it's included. If I have 4, it's included, sorry. If I have 5, it's included. But if I have 6, it's not included here. Please take note. So that means the same thing here. They say we should find the frequency. Okay, that means in this question here, they say we should find the overtone between 40 Hz and 150 Hz. Okay, the formula for overtone when it is not in a resonant tube, because they're not mentioning anything like resonance tube here. The formula is said to be Fn is equal to n plus 1 F naught. And this F naught here is said to be fundamental frequency. It's always given to us in the equation, or the frequency we calculate from the equation is said to be fundamental frequency, or it will be given to us in the equation. So here is given to us here. They say the fundamental frequency here, this one given to us here is the fundamental frequency, that is 40 Hz. So the 40 Hz here, that is F naught, is equal to 40 Hz. Please take note. So let's go. So let's first of all check when m, the first, when s equal to 1. So if m is equal to 1, this will be f1 will be equal to class 1 plus 1 times 40. Please take note. So 1 plus 1 is always class 2 times 40. What is my answer? 80 Hz. Okay. Now let's check when n is equal to 2. So this will be f2 is equal to, using this formula here, 2 plus 1 times 40. This will be equal to 3 times 40. What is the answer? 120 Hz. Now let's check when n is equal to 3, because this one here is within it's not above 150 here. That means it's included. Let's see this one here. M equal to 3. That means m of 3 will be equal to plus 3 plus 1 times 40. 3 plus 1 is always class. That is 4 times 40. What's my answer? 160 Hz. Class, 160 Hz is above this guy here. That means it's not included. Please take note. So how many overtone here that is between 40 Hz and 120 Hz? That means it's not below 140 Hz, but it's not above 150 Hz. Please take note. So what are the distance here? The frequency here is what? 80 Hz and what this class? 120 Hz. So how many overtones this class? 2 overtones. So the answer is what class? 2. Please take note of that. So now let's solve some questions here involving resonance tube. Question 2, please. Let's solve this question here. But before we solve this question here, let's try to understand the question. It said, in a resonance tube experiment, if the fundamental frequency of the vibrating air column is 280 Hz, that is F naught is 280 Hz. Please take note. It said the frequency of the third overtone is, now we know that there is a given formula in solving the overtone of a resonance tube. Please take note. And the overtone Fn for a resonance tube is said to be equal to 2n plus 1 times F naught. Please take note of this, okay? Now, we are asked to find the third overtone. So the third overtone means that n is equal to 3. So that means n equal to 3 here. This is going to be F3 here. Remember, will be equal to 2 into 3. That's replacement plus 1. Please take note. Times replacing F naught. F naught is what? 280. So now let's solve what is inside a bracket first. In mathematics, we simplify what is inside a bracket first before the outside. So let's solve what is inside this bracket first. 2 times 3 will give us 6. 6 plus 1 will give us what class? 7, right? So that means this is going to be 7 times what? 280. Please point your calculator. What is the answer, please? 1960 in what? In hands. This is my answer here. Please take note of that. Very simple. Okay. Now, whenever you are given any question relating to overtone, when it is not in a resonance tube, we use the formula here, Fm as m plus 1 F naught. But if it's in a resonance tube, at that point it's going to be Fm will be equal to 2n plus 1 times what? F naught. Okay. All exam possible question on JAMB. Hit the subscribe button to get all our exam possible question on JAMB. Okay. Thank you so much.